Well, everybody got stuck on the last two, so I'm still not going to update the solution guide for trigonometric limits 2, but I figured I should, I don't know, those of you that are interested, give you a little bit more. So I'll do the first one. I'm going to cross this out. I should have given myself more room. Oh well. And we're going to figure this out. So, there's a couple things going on here. Maybe I'll give myself more room. So the limit as x approaches pi of sine of x over x minus pi. So the first thing you should do is check for continuity. Sine of pi is 0 over pi minus pi, another 0. I guess this probably has a removable discontinuity, but what do you do? Well, it does say, hey, let a equal x minus pi. So that's going to be the limit as x approaches pi still. We won't change that. We'll do another change later. And I'm going to put sine here, but leave it blank for a second. And then, the obvious thing is put that capital A where x minus pi used to be. But the other thing is, ideally we can get sine of a over a or something like that, because we know, or at least hopefully we know, the limit as x approaches 0 of sine of stuff over the same stuff is going to be 1. I have to assume that's what we're doing. I mean, we'll see. And if I make mistakes in here, I'm doing it kind of real time without notes. And so I like when I make mistakes, because then it's like, hey, there's an error there or something. Anyways, so if a is x minus pi, then up top, x is equal to a plus pi. We could just add pi to both sides. So now we can replace the x in sine of x with a plus pi. By the way, the order doesn't matter. If you had written it as pi plus a, everything would work out the same. And so now the reason you were given the expansion for sine of a sum of angles is so we could, make that wider. Okay, so limit as x approaches pi of sine of a cosine pi plus cosine of a sine pi all over a. All right. I'm just trying to think what's going to happen with that x approaches pi in my limit notation. Well, whatever. What I know is cosine of pi is -1. So let's replace that. Limit as x approaches pi. Sine of a stays where it is, and cosine of pi is -1. Let's put an a over that just to be safe. And break that up, and we'll do cosine of a over a. Isn't going to simplify. And let's see, sine of pi, well, that's 0. Okay, that's nice and simple. Okay, so limit as x approaches pi of negative sine of a over a. Well, let's see what happens when we replace a with x minus pi. All right, undo that replacement we did. So negative sine of x minus pi over x minus pi. And so, man, there's a lot going on in this problem, so that's kind of fun. The big hint, I guess, even though this is not the limit as x approaches pi of sine of x over x, or sine of stuff over stuff, we can use our rule. Because it's like if we used pi as an input, we get negative sine of 0 over 0. So really what we're doing, how do I explain what's going on in my mind? I know how. Y equals sine of x over x looks, that's what we could do. Let's call it f. let's call this f of x is sine of x over x. Red's not good. Purple. Purple seems right. What would f of x minus pi be? Well, that would be, number 1, sine of x minus pi over x minus pi, which is a translation of f of x pi units right. Which means if the limit as x goes to 0 of sine of x over x is 1, then the limit as x approaches pi of sine of x minus pi over x minus pi is also 1. Except for that negative out front, so we need that negative. Dang, that could have been a lot better if I had planned better. Okay, so hopefully that makes sense. Oh man, I'm not on my iPad. I'd really like to move everything over. Oh well, I hope that helps.